Hello and welcome to a unit on loops, right? It's pre-recorded lectures for my Electrical Engineering 1520 course. And we are just now going to start talking about while loops in this lecture. This is our introduction to our first loops in C++. So like I said, this unit on loops will cover while statements, do while statements, so while loops, do while loops, for loops. We'll also talk about how the break statement works and the continue statement works. But in this part one lecture, we're just mainly going to focus on while statements, right? But just in general, right, a loop is a programming construct or a statement in the C++ language that will cause repeated execution of other program statements. So when we want some statements to run more than once, right, we're going to put them inside a loop so they can repeat the same series of statements over and over, right? So each loop is going to have a Boolean controlling expression. In other words, there's going to be a test that as long as the test is true, our loop will keep executing. When the test is false, the loop will stop executing, right? And as I just said, right, we have three different looping statements: for, while, and do while. The do while is probably the least common. The while is the easiest syntax-wise to learn and understand, and that's why we start with it. So the while statement in C++ has a general form of the keyword while, and then we put a test condition in parentheses. So while this test condition is true, as the flow chart shows over here, while some test condition is true, we're going to execute the code inside the body of the loop. And by loop, you can see this flowchart arrow says, okay, when you get to the end of the loop, you go back up and you rerun the test condition. We'll see that the initialization here, we're going to have some variable or some value that is going to control how often this loop runs. So we need to make sure that we initialize that variable to some known value. We'll come in, like I said, we'll run the test. As long as it's true, we just keep looping around. Right. As soon as the test becomes false, the code execution then goes beyond the boundary to the end of the loop and executes the next statement after that. So the important thing about a while loop is that the test is evaluated before executing the loop body, right? And that's what this flow chart shows. The test condition is executed before executing the loop body. That'll become important when we talk about do while loops. They execute the loop body and then perform the test. So while and for loops will always execute the test condition first before executing the statements in the body of the loop. All right. So we're going to start out then with a fairly simple example so that we can understand the syntax. And so this program is, so the output of this program is down here in the lower right. We can see that we're going to output, it outputs the numbers 0, 1, and 2. It does that by printing out the value of the count statement. So you can see here in our program inside main, we declare a variable of type int. Its name is count and it's initialized to 0. So it has some known initial value, right? Which is good because it's going to be used in this loop test condition. Here's our keyword while. We're going to say while count is less than 3. And while this condition is true, it will be true the first time because count will be equal to 0. 0 will be less than 3. This will be true. And then we start into the body of the loop, right? And so we typically use curly braces to indicate where the loop body starts. So left opening curly brace here says, okay, this is the start of the while loop body, as the comment shows. The right curly brace down here ends the while loop body. And these are the statements inside. So we have two statements. The way the language works is if you have just one statement that you want to execute as part of the loop body, you don't need the curly braces. But if you have more than one statement you want to execute, you need the curly braces. So I always advise students when you're learning to write this is to put the curly braces in, because if you ever want to go back and put it in a statement after you've written just one statement, right, it will be easier to modify. You won't have to worry about going in and adding curly braces. Basically, by getting in the habit of putting in curly braces, you will keep yourself out of possible logical runtime errors that you don't expect simply because curly braces are missing. Okay, so in here, right, we're just printing out the value of count, and then notice the next statement increments the value of count. And that's where we get the value of 0 printed out initially. And then we get to the end of the body of the loop, and the program flow goes back up to the test condition then. And we have incremented count from 0 to 1 because we added 1 to it. Count is now 1 while 1 is less than 3. That's true. We're going to come back in and then execute these statements. So we'll print out count, which is a 1. We'll then add 1 to count. So 1 plus 1, we'll store that back in count. Count becomes 2. End of the loop body, the program flow comes back to the test condition. So now we have, right, the number 2. While 2 is less than 3, while this is true, again, we'll print that out. We see we get our output of 2. Count is now 2. We add 1 to it. It becomes 3. Right, we get to the end of the loop body. We come back up here. While count, which is 3, 3 less than 3 becomes false. So the flow of execution goes to the line immediately following the end of the loop, which is a return 0 statement. Right. And so as the note says, this test condition count less than 3 is true 3 times, right? When count was 0, and count was 1, and count was 2. So printing out values of count to have an idea of how often a loop executes is a good way to get to learn the flow of execution, right? And then later we'll start performing other calculations within a loop. Okay, infinite loops. So what's easy to do, I tend to make this mistake a lot, so I definitely think it's easy to do, is here we have this example of we've got this variable x, we initialize it to 0, we say while x is less than 10. So remember, if you don't use the curly bracket, only the one statement following the body of the loop is executed. So while x is less than 10, we just want to print out x. Well, we get to the end of the loop, and the code cycles back up here to perform the test. Well, x is still 0, so we print out x, right? Another value of 0. End of loop, we cycle back up. We perform the test. As you can see, we don't have any code in there to actually change the value of x, meaning this test condition is going to be true forever. And so if you're running this code, you're actually just going to see really 0 printing out forever. Actually, let's just pop open Visual Studio, take a look at this. Right, this is our previous example of that for loop and things printing out the count 3 times. Let me just increase the size of the font here. All right, hopefully you can see that better now. Right, this is just our example. If we run this, this is the example we saw. Show the output popped up on my other screen, right? It shows we get 0, 1, and 2. All right. All right. So again, if we were to comment out this statement, and so count's equal to 0, while count's less than 3, we want to print out count. I've commented out the statement that makes this increment. Right, we'll just run this. My output shows up on another window. What you can see is this is just infinitely printing out zeros. Right. So like I said, it's an easy thing to do, right, is to forget to increment your count. Control C here will kill program execution, and yeah, it throws up this other file in Windows. I really don't care about that other file. All right, that stopped the program. Now order is important too, because you might wonder, where should you increment count? A lot of times, well, it all depends on your logic, but typically we'll increment it at the bottom of the loop. But here, let's just take a look at the difference. So I'm going to take count, I'm going to move it up here. So if we increment count before we print it out, we change the order. Sorry, my old window I didn't shut this down. All right, change the order. All right, now we can see we printed out count 1, 2, 3. Before we had 0, 1, and 2. Right, so the loop still executed 3 times. Right, the first time it came in, it performed the test, count's equal to 0, 0 is less than 3. We add 1 to count. So when we print out count here, count is 1. Right, and so we come back up. While 1 is less than 3, that's true. So we increment count to 2, we print out the value of 2. We come back up here, while 2 is less than 3, that's true. We then increment the value of count, which is why we saw the value of 1, 2, and 3 printed out this time. So if our program was supposed to print the numbers 0 through 2, the time at which in our program, the place at which we incremented the value of count becomes important. Right, so like I said, it all depends on your programming logic. This was just an example to show us how a loop executes. Here's another common error or pitfall. Right? If we were to run this program, so actually, let me pop this up. All right. So what I'm going to do here is right after the while count is less than 3, I'm going to put a semicolon. Because a lot of times as you're learning to write code, you're used to putting a semicolon at the end of your statements. Well, this is what's called a do nothing statement. In C++, the semicolon all by itself is a do nothing or a no operation statement. And so when you put this immediately after this, what happens is the test condition will be evaluated. So we'll have count equals to 0, while 0 is less than 3. So while this is true, it says do the one C++ statement following this, right? 1 because there's no curly brackets, and this is the one legal statement. So while count's less than 3, do nothing, and then cycle back. Oh, well, count's still 0. While 0 is less than 3, do nothing, cycle back. And so these statements, right, the C out statement will never execute. And so you've got another infinite loop here, right? And so I added the semicolon here. Let me rebuild that. Pop up our output window. You can see there's no output, right? Over here, Visual Studio is telling me the processor's running, right? But I've got no output. So I would sit here and I'd say, why do I have no output? And these are hard to notice until you get used to them, because a lot of times when you're programming, you look at this and you're like, oh, okay, well, that's true while count's less than 3. But you have to ask yourself, why is this statement, or in particular, this statement, not executing, right? One way is to use the debugger to start stepping through your code to try and see why it never gets to those lines. But the fact that this never prints out, you start asking yourself, why did this happen, right? Is this false to begin with? Well, it shouldn't be, because count's equal to 0. So with experience, you look for something like that semicolon, and then when you find it, you kind of smack yourself in the head a little bit and go, oh, I did it again. And you learn how to recover from that error. All right, so let's hit the stop debugging there. Bring up the next slide. All right. So that's basically it for an introduction to while loops. Got a couple other slides in here in the lecture about using postfix and prefix increment operators within the loop. Notice before we had a separate statement that added 1 to count. And what I'm about to talk about now is an advanced topic. It's not a desirable style of programming anymore. Years ago, it was a little more desirable, or people thought it was cooler. But the examples will hopefully illustrate why. So like I said, this is something that's advanced, but you should probably know why not to use it in case you try using this. Right. So postfix increment. Right. Postfix increment, then the increment operator, remember, is the plus plus sign. Two plus pluses together. And that's going to add 1 to count. Right. And what this is going to do is postfix says to add 1 to count after this expression is evaluated. Right. And we'll see that we print out the values of 1, 2, and 3, because this is going to be true. What's going to happen is that count's going to be 0. The value of the expression will be 0. It'll compare 0 less than 3, and then we'll add 1 to count. And so when we print out count, count will become equal to 1. Actually, let's just change our example back here. So count plus plus. We're going to get rid of this line. Let's run this. Again, all right, count's equal to 0. Post increment says to evaluate the expression first. So count will evaluate as the value of 0. Then add 1 to it. And so when it reaches this statement where it outputs the value of count, count is equal to 1. Now this works. If our purpose was to go through this loop and print out the values of 1, 2, and 3, right? That was very similar. Right? The way this worked was somewhat similar to when we said count equals count plus 1. We were incrementing count here before we printed out the number. Similar, but not exact, right? Because we have to remember then when we have count plus plus, postfix means that the increment operator comes after, post means after the variable name. And it also means that it adds 1 to the variable's memory after it reads what's in the variable's memory, evaluates that expression as 0. So that's that order of operations. And you can likely see, right? I shouldn't say likely see, the way I assume that you're feeling right now is when you read this, this is a bit confusing, right? The previous example we had, the initial example, this was very clear about what the value of count is when we do the comparison and when we increment it. And so this is a desired way of writing code. But sometimes you'll see people, you might run across an example that has a postfix or a prefix operator, because that used to be more common. But like I said, for making good readable coding standards, this is not the best idea. Similarly, if we don't do postfix, we can also do prefix. So prefix means to put the increment operators, the plus plus symbols, before the variable's name. And the way prefix works, right, it adds before. So what this one will do is it will add to count. So count's equal to 0. It comes down here and says plus plus count. So it increases count to a value of 1. And then it performs the test, is 1 less than 3. So it adds and then it evaluates the expression. And so in this particular example, with a prefix operator, this test condition will only be true twice, when count's equal to 1 and when count's equal to 2. And as you can see, right, the numbers 1 and 2 will print out. It will never print out a value of 0, simply because before this test is run, and before we print this out, we've initialized it to 0, we add 1 to it, and the first comparison is 1 less than 3. All right. Once again, that's a little bit confusing to read. Right. The other way is much more clear. And it also changed the number of times that our loop executed. So like I said, it's not the best idea to write code like this. You really have to know exactly what you're doing when you do this. And if you think about it, if this first test was count, this first test, the value of count was 1, why not just initialize this to 1 if that's what you need, and then add back in that statement count equals count plus 1. So again, this was an advanced topic. Again, at the end, I'm giving you a slide saying that this is cleaner code and it's clear to read, this form of increment, right? This coding style, that's what you were originally introduced to. Stick with it. As of this lecture is being done in 2021, that is the acceptable way to write code because it's easy for someone else to read, to know what your intent was, to have an idea of how many times this test condition will be true. All right, so that's it for the syntax of while loops. We'll do some programming practice in class, and you'll get a chance, of course, to use them in your homework.